This particular instrument will test a variety of physical parameters of any base oil or finished product that we have here at ChemLube. It is an automated viscometer by Anton Parr. Can be manually used without the auto sampler, but we currently have it working in an auto sampler configuration. We have software that will actually send the method and parameters and information to the instrument. So we will engage the instrument by logging in to the computer. It's just in a resting mode when you see that screen. And we will click on New Sample List in order to start a new analysis. You can choose the position on the auto sampler. I tend to choose position 5, 10, 15. As long as you know where you're putting the sample, it's fine. It can hold up to 48 samples. We're going to run our product of 5W30. In order to run the product, we need to transfer some of the sample. It's best to use a small sample cup. The objective is to not have any air bubbles. We have a clean test tube, and we will just gently fill without spilling oil. I tilt it to minimize the flow and so that we don't create air bubbles. So you want, the method specifies at least half to 2/3 full. That way when the plunger goes into the sample vial, it has enough sample to actually make it through the tube and to go all the way through the instrument and not hit a void or air pocket. So that's an appropriate amount. You never want to fill too close to the sample top because then it may overflow into the sample carriage. So that's an appropriate amount. So we'll sit it in section 5. Make sure it is completely seated in the auto sampler. If for some reason it does not fit in properly, it will cause the instrument to jam when the automatic arm comes in to try to find the vial. So make sure that it is seated properly and that the cap is seated properly as well into the test tube. So you leave it there. You don't need to touch the auto sampler at this point. We're going to tell it via computer what it has, and it is a 5W30 blend number 072518-289. This way we can identify on the output paperwork what product it was. We're going to request method 7, which is viscosity index. It's going to read the viscosity at 40 and then take the temperature profile up automatically to 100. It's also going to calculate the VI from the data automatically and calculate the specific gravity at 60, which we also need for our C of A's. There are lots of options and methods. This has programmable functions, but for our use today, we typically run method 7. So we click that. Make sure you verify the method is 7. If for some reason it is defaulted to method 0 or one of the others, allow it to go ahead and run the method. Do not try to abort in the system. Just go ahead and let it do and then reset and then set your sample for the proper method. Aborting the system tends to be cumbersome. It does a lot of resetting, and it's just best to go ahead and let it run on the incorrect method and versus doing an abort method. All right, so we're ready. We confirm that our rinsing bottles, which have heptane, have enough volume so that you're not sucking air in. These are filled on a weekly basis, but we're checking for that. Everything is in good position, and we're going to tell it to start the measurement. Now, if you were to have multiple samples, you simply would list each sample and the method of viscosity index and have them all in position before you hit the start measurement key. So now the auto sampler is going to go. There's a little foot that will touch the test tube and know that it is there in that sample position. Now this is the automatic sampling arm. It does have a lot of flexibility and an adjustment, and you'll see it'll start pressing down on that little stopper, kind of like with little air pulses, until it finds the liquid, what your sample is, and then it will start sucking up once it realizes it has made contact with the liquid. You'll see it move up the sample port, and you'll see it go through the tube and into the instrument. Okay, now it's going through the density cell inside the instrument and will begin to come up to temperature. You can come and check on the front panel of the Viscometer. While the computer is in control of the instrument, you don't want to touch any of these buttons. You can touch the info button. Pressing it one time will bring up certain values that you can look through. Now, since it's just pulled the sample in, you're not going to get any data necessarily, but it is telling you I'm on method 7, which is going to collect all the data needed to calculate a viscosity index, and it says it's currently trying to measure a sample. If it were rinsing or doing some other operation, it will tell you it's rinsing or at rest. So now we're starting to see data collection. The sample is inside the chamber. The heating block, or Peltier heating block, is at 40. Now it's going to make the sample come to a 40-degree point. It will start calculating the viscosity at 40 until it stabilizes within a certain range of error on that sample. When it finds the actual viscosity at 40 and is stabilized, it will then begin to ramp up to go to 100. And so you can watch the progress here as the temperature begins to move. But right now it's still trying to find the viscosity at 40 degrees. So you can see the number begin to fluctuate a little. It is reported in millimeters squared per second, which is the same as reporting in centimeters. Okay, you can hear a clicking noise and rinsing. The analysis is now done, and it is reporting out the 40, the 100, the VI. You can scroll over to info and see the specific gravity is 0.8532 grams per centimeter cubed. These other reports at 40 and 100 is simply another measurement. This is not the one we record for our viscosity at 40 and 100. You're going to scroll back and you can take the data from the screen, which is temporary, because once it rinses the cell, it's going to come back to a 0 reading, so you can verify. It's also letting you know that it's in a rinsing mode. So you can hear all of this taking place. This is all normal sound of rinsing and pushing out through a little compression, and then it's evacuating. We'll take a look over here of what's on our computer screen. You can see the progress bar is not at the finish yet. It includes all of the rinsing and activities until it goes back to reset to be able to do the next sample. However, we can go ahead and take a look at the output. It's the same information that was on the digital screen on the instrument, but here it is in an Excel format. That data can be exported and saved. And what we do is use the sample's name, which was a 5W30 072518-289 is the blend number. And we simply save it under that name. So because I've already run this sample once, it's in the system and it's wanting to know, do I want to replace it? So then, since this is just a test sample, I'm not going to save the data a second time and override my file. You simply can wait for the analysis to finish. You can indicate your data on our QC sheet, but we do always print out and store an electronic copy of the output, and we attach it to our QC sheet. All right, so here's that report. We're going to simply go down to the print manager, properties. In order to fit on one page, we'll do landscape, and then it will print on the printer directly below the instrument. And so you have your data that you need. The viscosity index is calculated. The viscosity at 40 and 100 are your first two columns, and then the specific gravity is also recorded. From that, then you can calculate your API value and your pounds per gallon. And that's the end of the analysis. You will simply take the sample tube out of the carrier, the auto sampler, and then it will be sent to be cleaned. In order to do that, a tool is used to pull the plunger out, and it'll have a little resistance, and then it is discarded. We do not reuse those, and then it is emptied, and then will be cleaned and reused.